All right, so we got our 45 tooth sprocket in. It's like almost a 1/4 inch thick. This is the plastic piece that it has to literally go around. Um, and I already have the chain engaged fully. So, yeah, there's a little bit of welding room there. Kind of. I don't know. The other thing is, I only have so many options for gear size. It's got to fit in here too, you know? I mean, the next size up was like 8 inches. I think this is 7.5. So an 8 inch would work, barely. Um, and this is a $30 part. $33. I know. I shouldn't even be spending that much. I should tear an old bicycle apart. You can tell me that. I know. Um, I'm not saying I can't do it. Just don't know if I want to do it. All right, so we got a couple options. I can't put it in the 4-jaw like that. Too big. So we can set it on a rotary table, which I don't think I have one big enough, really, because all my stuff is pretty small. The other thing is we could do a faceplate operation where we bolt it down to the faceplate just super perfectly, and we'd have to drill some holes, and we'd be holding it on spacers. A lot of setup. Or we could take something kind of big. I'll spin this down the rest of the way till it fits, in the center hole. And then we could weld this around. That way it has enough support and it'll be sitting flat on the disc. And then we would basically have to like part this off, which is not a great operation either. Here is the biggest rotary table that I have. And again, I'd have to hold it. By holes on the inside. And I'd only really get one shot at milling it out to the right dimension. I could never come, because there's just not enough meat out here to bolt it down to anything. And I would be sitting here cranking forever. All right, we're going to start with a faceplate operation. May not work the way I want it, but at least it'll give us a score line around it where we want. So I've centered this by eye on the center, and I just used a marker. I'm going to go with an undersized hole, probably like 3/8 or something, so I'll still have adjustment room. All right, so we got them in there. We got them spaced. I still need to drill. This hole's just a little bit too far out, so I'm gonna have to drill a second one. Fortunate, and they all clear just over the cross slide. I put a dead center or a live center in, and I've gotten a rough lineup. By that, I snugged up the bolts, and I just kind of went tap until I got the hole, with a little bit out, lined it up, tap, rotate, tap. So now it's pretty good. And so now I will do my final true and drill that, tighten it, and then drill that other hole. Right, so we've got it dead on center. It's kind of a small bit. So yeah, a little shady. We'll at least get a good score. Here's my super precise measurement style. We know what the diameter is, so now I set it to the radius, and I'm going from my dead center to just outside my cutting bit. It's a little cut, just a little bit wider because we need clearance, so it's not like a super precise thing because we're going to be welding and spacing. All right, so off we go. We got the gibs tightened. We have everything aligned, very sharp cutting bit, and we're just going to go with a nice, very slow cut. Well, it's going pretty good so far, no problems, but we bottomed out our bit, so now we gotta find another one. So this bit is, you can see it's advanced on this side, so we're gonna have just a little bit to clean up with a burr, but I think it'll be okay. All right, so here is where we are. We have a nice sharp little razor's edge on there. But I think we may have been given a gift actually, because the way it works out through no planning whatsoever is that is just barely on the inside. All right, so having that lip left on is actually perfect because it lets it sit just right on top of this rail. And it gives me just that little bit extra welding space. So I think I'm just going to weld these two together. Now I'm sitting here when I've adjusted this and I'll played with it a couple times and feels like I need about 2 or 3 pounds of force to rotate this. And I'm a little bit worried, like, because the plate is down here, you know. So even though it's not very much, it's only like 1.5 inches or so. Force on here could introduce a binding down there, but I'm sitting here and playing with these, you know, that's what I'm turning it on, and it feels pretty good. So I don't think that's any concern. All right, so we're welding at night. We got the light on so I can see through the lens, even though it's auto darkening. I still need a little bit of help. Now, this is kind of a delicate setup. That ring can move very easily, at least when I first start. So the only way I can, and these are small pieces and delicate tacks. So what I have to do is, I only have so many hands and I can't put the ground right on it. So I'm using the screwdriver as my ground and my poker all at the same time to keep things in place while I weld. It's working pretty good so far, and I'll just finish up a couple more of these little plates, and then we're going to give it a test. All right, that is full chain engagement, and it looks like we are just going to make it. And down here is a screw head that we are just clearing as well. I got a temporary chain on there. I'm just kind of tensioning that by hand. And we're going to test out the motor and the speed. Can hear it bog down sometimes. The speed's not bad. It could be just a touch faster. So it's not really that the motor's not strong enough. It's that this is a crap mechanism. Like, you know, I've adjusted it and played around with it. Sometimes it's nice and smooth. Sometimes it just sucks and binds up. Now, I mean, I'm tempted to redo this and some other guaranteed smooth mechanism instead of this shit. Another thing I could do is it is kind of the big brother of this little guy. So this guy here was like $14. And this one here, I think this one's about 2.5 times stronger. It looks like a much nicer motor and a much nicer build. You can also see from the output size that they expect it to give more torque. So I don't know. This is nice that we got it all done, but I don't think it's strong enough. But again, the problem isn't really this. It's this mechanism that binds sometimes. So just kind of by hand, I applied force down at this bottom edge right where the plate is. And I mean, I was afraid that by applying force up here to the top, I'd be introducing some kind of binding, and it does. It's smoother. And I mean, that's why they put the gear down here. They know that too. It's just that was such a great place to put the gear. All right, so this is a Lazy Susan bearing, and it moves very nice and smooth. But there's a couple problems with it. Number one, I started with a 6-inch. It was like, this was $5 or something. You can see that in the corners, the 6-inch on the outside doesn't quite clear here. Now, on the edges of the chutes, I could add like a little wedge just to help funnel. I don't think that's a deal breaker on its own. I think that'd be okay. And I mean, I really like having the bearing motion, so I definitely want to put some kind of bearing in there. I think it'll solve all my problems, but I don't think this is the one. I didn't read the description carefully enough, and this is not even plated. This is just stamped steel, so this thing would immediately start to rust. In terms of, even if I had a plated one, I'm going to always have to keep that packed full of grease, which is okay. Like, if I keep that packed full of grease, I think that it will maintain its smooth motion for, like, years. You know, if I had to replace one of these, like, every 4 or 5 years, totally cool with that. $10, 5 years, not a problem. Because it's just a nice motion. So I have one more of these coming that's out of aluminum. We'll see how that goes. It's a bigger diameter. All right, so we've received our other Lazy Susan. It's an 8-inch diameter, and it's all aluminum, and I think it's outdoor rated. And it fits over that, and it fits between the plastic here. And this is like exactly the right size to line it up nice and easy. we must be concentric in however we do our bearing with the metal gear tooth. Otherwise, the chain won't run right. So it'll be pretty easy to line it up with that. I have some slight concerns. I mean, aluminum to steel ball bearings, there could be like galvanic corrosion in there. So this is a strong possibility, and it'll be pretty easy. It already has all the mounting holes, so I know I'm not going to hit bearings or anything. And then I had another idea of what might even be better. So this is the center that we cut out. It'll be pretty easy to line them up to be concentric just because it fit, you know, very precisely in the spot that is missing there. So imagine that the center of this was cut out. And so imagine this is a bearing. And on the outside of the bearing, I pressed the bearing into an aluminum sleeve that has a notch cut in it that's just a little bit wider than this. So the three bearings would form a track that this disc could roll within. Well, and I decided to go for it. I started doing the other one. I'll go back out there and show you in a minute. So I started turning these custom rollers to go around the bearings there. I have two of these small ones and one bigger one. And this fits, you know, just about perfect in there. So I know I'd bored. You know, you had to be really careful boring it because you want just a slight press fit on the bearing. So I bored it deep, and you know, I was able to do both at the same time with the right bore. And now I'll just part these two off, and then we have our two. All right, so we have our two roller bearings, custom, you know, and those are the bearings that's going to go in there with a nice press fit. This piece of steel that I came off of is actually a little bit interesting. So I've had this piece of steel for like 20 years. I got it in a junkyard. I needed a set of step pulleys, and the machine that the step pulleys were on was like a 1920 something. So literally this hunk of steel has been around since at least the 20s. It's been sitting in my possession for 20 years, and I don't know. It's kind of cool to have something super old that you end up turning into something new, you know? All right, so for the last bit, I have one bigger bearing because I've only had two of those, but it's going to work out good. And the reason I'm going with one bigger one, those two are going to be solid mounted just with a stud. And then the third one, I need to be able to adjust in and out. So what I'll do is I'll turn an eccentric that goes in there, and it's nice that we have a larger diameter inner race so we can do that. And you'll see what that means in a second. All right, so I started mounting up the Lazy Susan bearing, and I'm using wood as a template because cardboard isn't strong enough for what I have to do, and it's still easy to work with. I drilled and tapped those holes so that this is how I was thinking about mounting it. Like the problem is it's going to be a little bit hokey. I mean, it'll work. It's a little hokey. And the offsets on these is not the same on every single one. One of them was different. And I was just like, you know what? It's already going to be a little hokey, so screw it. I'm going to do it right. Because, you know, but I don't entirely know how long that bearing would last, even slathered in grease. I think it'd be okay slathered in grease, but whatever. So we spent the night. I spent my Friday night. I now have three of these, two small ones and a big one, and they will cup this quite nicely. Bearings are kind of a press fit in there. I made them 1 thou under, so the bearing isn't jacked any more than that, and the bearing would not run smooth anymore. And I also made an eccentric, and that goes down into the center quite nicely, and that way, as I rotate the head, its center changes quite a bit, so I can, you know, this will adjust in and out, so that way I can get a nice running fit on the disc. And those two can be stationary. Right, we did a quick mock-up just to make sure that our expectations meet reality. And it's running nice and smooth, and it doesn't have much play. And you can see the eccentric in action here. You can see how the adjustment So you can see how that works. All right, so for the last little cut on this one, because the blade angled this way, we've actually flipped the blade upside down and we'll run it in reverse. I'm only doing this to finish the cut because at the beginning of the cut, all the forces I want to keep it, turning and threading it on. This would actually, that's already really tight now because of the parting operation, but in this mode, it would actually try to unthread the thing. So I just reserve it for the end. On the sound of it. Whoops. And we unthreaded. So essentially the edge just caught as it was breaking through, and I didn't have to do any more turning. I just gave it a little wiggle and it popped off. So we have a pretty good fit there. So there's one other potential flaw that I just realized when I put the ring on there, is that the weight of the chute is fair and the thickness of the metal is thin. Before, they had all of this engagement area like all the way around. So really the load was spread out over all of that. All right, so I don't know. It works pretty good. Another thought I had is in a high vibration environment, just having the friction of, just that screw to hold this, if there's not much adjustment, all that has to do is tweak just a little bit and that ring will drop out because it's not a very deep engagement. So another thing I could do is weld a disc onto here and then have the disc clamped down with like a bolt or two on the side. That would make it so that it was much less prone to movement, had a higher clamping force than just one in the center as the pivot. And ideally, I guess this ring, the rotating ring would be, outside of the diameter of the teeth. I don't have the material for that on hand. I'm going to play with one other idea. I like this. Don't get me wrong. And it's working well. We'll see. All right. So the last thing that I want to experiment with is because this stock collar isn't wide enough to bolt down to the ring without some extra kind of clamping, bracketry. I'm going to kind of build my own collar. The only plastic that I have is some old deck, the plastic decking, and it's not really wide enough on its own, so I'm going to have to do it in two pieces. So right now I'm going to rough it out on the bandsaw. I'm going to give myself a little bit of clearance on the inside and outside. Then I'm going to clamp it into the lathe, and we're going to spin up the final diameters, and then the idea is that we'll bolt it in several places to the chute, and then we'll have enough material here to bolt it down to the rotary table, or the Lazy Susan, rather. Actually, this material works easy enough and cut easy enough with the bandsaw that I just did it right to final size just on the bandsaw. All right, so here's the last thing I'm going to try before I go to welding on that ring. I got a piece of decking. I had to cut in and inset the things. I had to cut my bolt heads off. I screwed this in from the bottom and with spacers so that this could, I had to put a nut in there as a spacer so that this could rotate. Now, in order to mount this to the thing, now I'm going to have to tap these inside ones like I tapped the outside ones, and I'm going to have to put bolts up from the bottom. All right, so we have our bearing installed, and it all moves very nice and free. It's a little bit of a pain in the butt to clamp all of these different pieces together, and it has to go in a very specific order of operations, so that's kind of a pain in the butt. But this little motor now is plenty of power to do it. The chain's still at the same angle and everything, but the motor doesn't even struggle because, now we have a proper bearing mechanism in there. And chute rotation's adequate. It could be a little bit faster, but no need to get too fussy. So now the only thing that I don't know is, I'll go on a little field trip here. All right, so I have a gap here and I have a gap here, and those could pack with snow. They could, and this could get harder to use. and that bearing would freeze up. And I don't know, I could put another piece of metal in here as like an inner liner to come up to about, the top of this. And that'd actually be quite easy to do, especially once I switch over to having the metal piece down here. So I'm kind of going back in my mind now, like how the hell I got to this point and just spent like an hour. No, I mean, probably half an hour of video time and like 2 days just working on this bearing. When I bought it, I knew that this mechanism was going to be problematic. Like I didn't want to buy a snowblower that had this. But it's what I found, and I had to drive an hour just to find this one. So I live in a small area. Now, maybe I could have got along with that if I had just bumped up and used a more powerful motor, or even a more powerful motor. Like, I mean, this would have spun it without a problem. I'd be drawing more battery life. I mean, it'd be drawing more battery, but it doesn't get used all that much, so I don't think it'd kill my batteries. I had already built a waterproof enclosure for this little guy, and this seemed okay on initial tests, and I had already machined like the sprocket and everything. So part of me going crazy on the bearing, number one, I like a good mechanism, but number two, just, I was already invested. So, and then the last thing that I kind of want to cover, and I'm going to wrap this is going to be the end of this video here, because like we've already spent way too much time on this. And I try to keep these at like 15 to 20 minutes. When you're doing prototyping and experimenting, you don't always know what is going to be the best way forward, or you have to be ready to fail. You have to try things. If you can't see too far into the future, you have to be willing to start moving in one direction and see where that brings you. Like look around and say, oh, I'm in a swamp. Oh, I'm in a forest. Oh, this is fucking candy and unicorns. So, you never know. In this case, maybe this is the final one. Maybe it isn't. It's what I'm going to start with for now. It seems like it has more support than the ring. So I don't know. We'll see.